What would happen if the moon disappeared? The moon, Earth's only natural satellite, has been a source of inspiration for humanity throughout history. From ancient myths to modern science, it has been a symbol of mystery, beauty, and the unknown. It has guided our calendars, lit our nights, and fascinated poets and scientists alike. But have you ever wondered what would happen if, one day, the moon simply disappeared from the night sky? How would Earth cope? Could life as we know it survive without it? Let's explore this fascinating what-if scenario. In the early days of our solar system, our planet didn't have the peaceful orbit it enjoys today. Instead, the solar system was a chaotic, violent place, filled with wandering protoplanets, giant rocky bodies constantly colliding with one another. Among these was a Mars-sized protoplanet named Theia, which collided with the young Earth. This catastrophic collision ejected a massive amount of debris into space. Some of this debris was captured by Earth's gravity, coalescing over millions of years to form the Moon. The Moon's formation took about 30 million years, a brief period in the grand timeline of Earth's 4.54 billion-year history. If we were to compress Earth's entire history into just one single day, Earth would form in the very first second, and the Moon would appear within the first 10 minutes. In its early days, the Moon was much closer to Earth, about 15,000 miles away, compared to its current distance of roughly 240,000 miles. To put this into perspective, at the time of its formation, the Moon was only about half the size of Earth's circumference away from the planet. If the Moon were still that close, it would appear 15 times larger in the sky than it does today. Such proximity would have meant much greater tidal forces on Earth, causing extreme temperature fluctuations, which would make life on the planet impossible. Thankfully, the gravitational pull of the Moon caused Earth's tidal energy to transfer to the Moon, gradually pushing it further away. This process has been ongoing for billions of years. Thanks to precise laser measurements, we now know that the Moon moves about 1.50 inches farther away from Earth each year. But what if the Moon were to suddenly disappear? Would Earth crumble and fall apart immediately? The answer is, surprisingly, no. Not in the immediate aftermath. If the Moon were to suddenly vanish, Earth wouldn't crack open or explode, though we would notice some significant changes. The most obvious change would be that the nights would become much darker. We already experience a glimpse of how dark Earth would be during the new moon phase, when the Moon is not visible at all. To understand just how much darker it would get, we can look at the concept of magnitude, a logarithmic scale used to measure the brightness of celestial bodies. The Sun has a magnitude of negative 26.74, while the full moon has a magnitude of negative 12.74. The difference in brightness between the two is enormous, about 301,995 times. During a new moon, the moon's magnitude drops to negative 2.5, making it 12.5 times less bright than during the full moon. Without the moon, our nights would be about 10 times darker than they are during the new moon phase. While this wouldn't result in total pitch-black darkness, it would still make the nights significantly darker and less luminous. The positive side of this is that without the moon's light, the sky would be far clearer. The Milky Way would be more visible, and we might even see some of our neighboring galaxies, like Andromeda, more clearly. However, this newfound clarity comes at a cost. Nocturnal animals that depend on the moon for navigation would struggle. Moths, for example, are already impacted by artificial light in cities, which interferes with their navigation at night. Without the moon's guidance, they would face even greater difficulty, potentially impacting their ability to reproduce and survive. Sea turtles, like the loggerhead, rely on the moon's reflection on the water to guide them to the ocean after hatching. If the moon were to disappear, they would no longer be able to navigate properly, making it much harder for them to reach the safety of the sea. Currently, only 1 in every 1,000 turtle hatchlings survives to adulthood, and without the moon, this already small survival rate would drop significantly. As soon as the moon vanished, a gradual silent extinction process would begin for these and other species. Beyond the darkness, one of the most dramatic immediate effects of the moon's disappearance would be on the tides. The moon is responsible for around 2/3 of Earth's tidal forces, with the sun contributing the rest. If the moon were to suddenly vanish, tidal waves would decrease by roughly 50 to 67%, which might seem subtle at first. But tides play a vital role in sustaining coastal ecosystems. Marine creatures like crabs, starfish, and mussels depend on the nutrients carried by the tides to survive. These species, along with others in coastal and marine environments, would be forced into competition for these vital resources, potentially leading to a disruption of the local food chain. While the immediate effects would be noticeable, the long-term consequences of the moon's disappearance would be even more profound. One of the moon's most important roles is stabilizing Earth's axial tilt, which is responsible for our planet's seasons. Currently, Earth's axial tilt is about 23.4 degrees, but over the course of 41,000 years, this tilt oscillates slightly between 22.1 and 24.5 degrees. The moon's gravitational influence helps stabilize this tilt, ensuring relatively stable climate patterns. If the moon were to vanish, Earth's tilt would become unstable, causing more dramatic fluctuations in its axial tilt. Over time, this wobbling would lead to extreme climate cycles, with glaciers covering much of the planet, much like during the Ice Ages. In comparison, Mars, whose moons are too small to provide sufficient stabilization, has experienced wild temperature fluctuations due to its unstable axial tilt. These fluctuations have led to extreme seasons. It's fascinating to consider what would happen if the moon had never existed, or if it had vanished early in Earth's history. The moon's gravity is gradually slowing Earth's rotation, about 2 milliseconds every 100 years. If the moon had disappeared 4.5 billion years ago, Earth's rotation would have remained much faster, and the planet's day would have been only around 4 hours long. This would have had significant effects on the development of life on Earth, with rapid day-night cycles potentially altering the evolution of organisms in unpredictable ways. Another intriguing consideration is whether the moon's disappearance would alter Earth's orbit around the sun. Both Earth and the moon orbit a common center of mass called the barycenter, located just inside Earth's surface. If the moon were to vanish, this barycenter would shift, which could slightly change Earth's orbital speed and the shape of its orbit, only about a 0.041% variation in Earth's orbital speed. Over time, this might slightly affect Earth's proximity to the Sun, though it would not have a major impact on the planet's overall climate. It would hardly be noticeable, especially in the short term. Beyond the physical and ecological consequences, the disappearance of the moon would also have sociological and scientific impacts. The moon has played a key role in human culture, from calendars and mythology to scientific discovery. Its sudden absence would likely affect cultural and social practices, as well as scientific fields. The moon has been essential in preserving records of Earth's history, especially from the early stages of our planet's development. These records could be lost if the moon were to vanish. Additionally, the energy required to remove the moon from its orbit would be enormous, equivalent to detonating a 1 megaton hydrogen bomb every second for 288,000 years, a mind-boggling force that would likely cause widespread panic. While the loss of the moon would undoubtedly bring significant challenges, it's important to remember that life on Earth has already endured far worse events. Evolution is incredibly adaptable, and while many species would face hardship and even extinction, life would likely continue. The process would unfold slowly, with long-term impacts taking millennia to manifest. It's easy to assume that the current state of Earth is the only or best possible scenario for life. But as we explore the universe, we discover countless other possibilities. Planets with conditions that might be more favorable for life than our own. As we continue our search for knowledge in the vastness of space, one thing is certain: the universe holds endless possibilities for discovery. What lies out there waiting for us? We'll explore that in the next video. Until then, stay curious and take care.